Good evening, students. We are in unit number 2 and discussing about various construction equipments which are utilized to to execute specific operations efficiently. In this series of lecture, we have discussed about the working of the dozer, then ripper, and working of scrappers, different types. And now we are going to discuss about the front shovels. Front shovel are me- power operated shovels, and their working action is from down to up. So the bucket of front shovel faces upwards, and the cutting operation is from low to high. Front shovels are very useful equipments, and uh, they are available in various sizes. Uh, Front shovels are used while mining and related activities. Now we shall see a video of working of front shovels, wherein we will concentrate on its working principle, its cycle time, and its efficiency issues. Please have a look, and then we will discuss about the particulars of it. See, the front shovel is waiting to load the material because filled truck has to move out and the empty truck has to take its position. This is considered as a wastage of production time. See, the component of the cycle time of the front shovel is cutting, means filling of the bucket, lifting the material, swinging to load at the truck, releasing the material, and return back to its cutting position, and maneuvering to take the position for the taking the cutting position again. Again, filling of the bucket, moving to the truck, releasing the material, returning back to the cutting position. See, the truck is standing at 90 degrees to the front shovel. This is considered to be very efficient because in this operation The shovel needs to move only 90 degrees from the cutting position and return back only 90 degrees, one quarter of the circle. After filling up the material, filled truck moves and empty truck is going to take its position. Here you can see the maneuvering time of truck is higher. Front shovel has bucket is filled. Shovel is waiting to load the material. Truck came into the position, dumped the load. See, this front shovel is working on two sides. One side is in front of it, from where the loaded truck is situated at the 90 degrees of rotation, and another face which is perpendicular to the query ledge. This face is 180 degrees to the loading to the truck. This shovel is doing the open mining, wherein it is removing the top laying material separately so that the below bed may be excavated separately. The equipment planners should plan about the path of the trucks in such a way that the truck easily filled truck easily move out from the position from this position, and an empty truck may able to take the new position very quickly, so that shovel need not to be kept standing. See, this shovel is waiting. So if this truck is can come in this way, so that this truck may take the load. One more important thing while deciding the bucket capacity of the shovel is that uh, the capacity of the bucket of the shovel should be in multiple of truck's capacity. Suppose if a shovel has 5-meter cube capacity and the truck has 20-meter cubes of transportation capacity, then the truck will be filled in 4 full bucket load. And if the transportation truck having is not in the complete multiple, say truck is having 23-meter cubes of the transportation capacity and bucket volume is 5-meter cube, then it will take 4 buckets full and 1 partial bucket to fill the entire truck. This will create a deficiency in the process, wherein the last fifth bucket is not fully utilized, and that cycle time is having that cycle time will not produce the desired output completely. So, effort should be made in such a way that the truck should take the full bucket capacity as you are seeing in this operation. This truck is sprinkling the water at the mining site to ensure that dust should not be there in the air, and ensure proper visibility for all equipment operators. You have okay. So we are there are few equipments. This is the chain track. This is the operator's cabin and the machinery. This is the boom. This portion is called stick, and this portion is called bucket. Now we shall move to the specifications of front shovels. Now you have seen the working of front shovel, and it is predominantly used for hard digging above the track level and loading haul units. Loading of short rock would be a typical application where you are seeing in the figure. Shovels are capable of developing high breakout force with their bucket, but the material excavated should be such that it will stand as a vertical bank. So, as I have told you, this front shovel is called front shovel just because its working action. The bucket in this machinery is facing upwards, and it is cutting above its track. So the machinery should stand on the level, and it can cut in terms of vertical banks. And the versatility of the front shovel is and the efficient main advantage of the front shovel is it can cut very hard material and exert quite a heavy force on the material, and it can also load the transportation unit by itself. So it does not need any loader to complete the operation. It completes the operation by cutting the material, swinging to the transportation unit, and it also fills the transportation unit. The front trowel has following components. This is the operator's cabin and the main machinery. And first arm is called boom, and consequently, this stick which is moving the boom is called boom cylinder. And second portion is called arm or stick, and this cylinder which is moving the stick is called stick cylinder. Third main component is bucket, and the hydraulic cylinder, which is controlling the movement of the bucket, is called bucket cylinder. Employment of a shovel. After the bucket has penetrated and filled the material, it is rolled up to reduce spillage during the swing cycle. For estimating the production of an excavator, it is necessary to know the volume of material actually contained in one bucket. So we need to find out the bucket capacity which is actually present at site with the actual material. The struck capacity is the bucket capacity when the load is struck off flush with bucket sides. So you can assume the struck capacity means one in one go one strike whatever material it cuts, and the load is struck off flush with the bucket sides. It means there is no heaping. Then that capacity is also taken as bucket capacity. Another capacity which is called water line capacity. This assumes a level of material flush with the lowest edge of the bucket. That is, the material level correspond to the water level that would result if the bucket were filled with water. This is called the water line capacity. And next is the heap volume capacity. The heap volume capacity is can be placed in the bucket without spillages based on a specified angle of repose for the material in the bucket. As we have seen in the video, that bucket is not having the water line capacity because it is excavating the rocky material, and you can easily see a heap created into the bucket. So actual volume which is taken up by the bucket in one go is more than the volume of the water line volume of the bucket. Now, since bucket ratings of shovel are based on struck volume, it is often assumed that the heaping of the bucket will compensate for the swell of the soil. It means the when this material is being excavated by front shovel, it contains more material in form of heap than the struck capacity. So it it is assumed that whatever swell has been done for the material is compensated by that extra heap. So you can directly calculate the bank cubic yard using number of bucket filled by the shovel. So, a better estimate of volume of material in one bucket load will be obtained if by the nominal bucket volume is multiplied by the bucket fill factor or bucket efficiency factor, because it is depending on the type of material which is being excavated by the shovel. Now, shovel production. Actual production of shovel is affected by various factors which are listed here. First, class of material. Second, height of cut. Third, angle of swing. Fourth, size of hauling units. Fifth, operator skills. Seventh, sixth, physical condition of the shovel. This is the production formula in meter cube per hour, wherein it considers all the factors related to the production aspects of the shovel. So production in meter cube per hour will be working seconds per hour divided by total cycle time. It means you are basically finding out that how much cycles are going to be done in 1 hour. Now multiplied by heaped capacity in loose meter cube, this will give you the total volume, theoretical, multiplied by fill factor, multiplied by height or swing factor, and operator efficiency. This will make the calculation actual and as per the conditions of site. So This formula is deduced wherein you can find, by putting the value, you can find out the production in meter cube per hour, where Q is heap bucket capacity, F is bucket fill factor, A is ratio D, angle of swing and depth or height of cut correction, TC is cycle time in seconds, E is the efficiency in minute per hour. Now we shall see a, a table which is indicating about the bucket fill factor. If we are working with such a material which has a cohesive type of nature, this ensures more better fill factor as compared to the loose material which may easily slip from the bucket while filling. So bank clay and earth have the fill factor up to 100%, 110%. Rock earth mixture even better, 105% to 115%. Rock poorly blasted. See, poorly blasted rock have lesser fill factor than the rock earth mixture, because poorly blasted rocks may left a lot of space in between, in between them, so that the bucket is not working up to its full capacity. Well blasted rock is filled by entirely by bucket, and during heaping, additional 10% may also be transported. Shale, sandstone, standing bank will have lesser bucket capacity because of the presence of voids between the material. Now, this is a very crucial table, and please have a look. The factors for height of cut and angle of swing effect on the shovel production. As I have discussed during the video, that the shovel is basically working above its track, and the action of cut is from low to high. So, uh, the efficiency of shovel is depending upon at which height it is cutting. So if the height of cut is in degrees is very high, then the production of a shovel is very less, and it is less likely that the front shovel may fill its bucket. So if it is cutting at the top of the query ledge, and because of the high length of the boom and length of the total reach, it has to stand very near to the query ledge. This shovel is not working up to its full capacity. And if the shovel needs to fill its bucket at very low angle, so shovel has to go very low, and it will also make it trouble to fill the bucket, and it will also waste the time. So the best position for the height of cut of a shovel is in between, and it is not at the top of the query ledge and not at the bottom of the query surface. So you can see the if percentage optimum depth will be in terms of percentage. For lower percentage, see the lower value of the efficiency, and as the uh, angle increases, its efficiency start increasing till at the point of 100-degree angle, means just above the same height of the operator. And when it reaches to the maximum, and as the height of cut further increases to the top of the query ledge, the performance is starts decreasing. And angle of swing is also very crucial in the production of the shovel, because as I have told you, when the truck is standing at the side of the shovel needs to move 90 degrees to fill the truck, and coming return back to 90 degree to fill the bucket again. If truck is due to any reason or uh, width available in the query, or due to any reason, if if transportation unit is not able to sit very near to the shovel, it it has to fill the material by swinging a lot. That's why the efficiency, due to the more swinging needed, the lesser efficiency has the of the shovel. You can see in this table that a 45-degree angle of swing is best suited, but it is very rare, because in front of the query, uh, this 45-degree angle is obstructed by the query face itself. It, if it is not working at very outer edge at the query, and but the angle which is 75 degrees to 90 degrees is quite possible, and uh, we should avoid the angle more than 90 degrees in every case. But if it is some special situation, and whereas if width is not available to park the truck, and because of the issue that one you have to give the space for filled truck to move out, and empty truck to take its position. So the available space and the route of the loading unit shall be scheduled in such a way so that filled unit may move easily out, and empty unit may take its place during the cutting action of the shovel, so that shovel need not to wait for truck to take its position and fill it again. So as you can see that while swing as if shovel needs to swing more, its efficiency goes down. See, at 45 degrees it has 0.93 factor, and at 60 it drops down, then it keeps drop down till 180 degrees. Means the truck is standing just below, just behind the shower. So depending upon these two factors, this production chart can be used. So if you want to find out the ideal situation, so you can see this one is lying in just middle of the chart, wherein the angle of swing is 90 degrees, and depth percentage depth of cut is 100 degrees. So at this position, you can assume it that at this position the output of the shovel is balanced, and at the 100%, it is working at the 100% capacity. Any addition in terms of angle, or any reduction in terms of angle of swing, may give you some better response, which can be seen by this box. So this box is at the advantageous position than the standard 90 and 100%. So if the cut is from 45 to 75, and the percentage depth of cut from 80 degree to 120 degree at least, you are able to have a better production rate than the normal. And this position is considered to be best for all the available cases wherein angle of swing is what minimum 45 degree and depth of cut is at 100 degree. But this type of situation is very hard to achieve, and it requires a lot of favorable factors for the managers. If it is available, then you can get benefit of it, but nevertheless, try to achieve this figure. The height of cut of the shovel on production is discussed, and we have seen about the in the table about this percentage of cut. Elements in production cycle of a shovel. See, there are four elements as discussed in during the video. That first operation of the cycle time is load the bucket, which take 7 to 9 seconds depending upon type of material and type of shovel. Swing with load will take 4 to 6 seconds, and this 4 to 6 seconds depend upon the angle of swing. And the swinging action is carefully taken because very rapid swing may result into the collision with the loading with the transportation unit, and quick rapid swinging is not permitted. It is the safety issue and may lead to the accidents. So speed of swing is almost same for all the equipments, but the time variation is due to the angle of swing. If the machine, if the transportation unit is standing at 75 degrees to the shovel, and if it is standing 120 degrees to the shovel, it will take more time to swing the load to the transportation unit. Now, after reaching the transportation unit, dumping will take 2 to 4 seconds depending upon type of material and depending upon the volume of the bucket. And the return swing will be much quicker because it does not carries load, and the return swing will does not have accident or hazard issues because the return swing is moving towards the query ledge. So if bucket is touched to the query ledge, then it will not cause any damage to the any machinery. So this whole cycle is divided into these four parts: and load the bucket, swing the bucket with load, dump the load, and return this return swing. And every manager should very minutely evaluating every aspect of the cycle time and tries to reduce as much as possible, because this in turn leads to the overall production in of the site. These factors are discussed in very already the class of material, angle of swing, etc. Now consider an example for the front shovel. A shovel with 3.82 meter cube heaved capacity bucket is loading poorly blasted rock. It is working 3.65 meter height phase. The shovel has a maximum rated digging height of 10.37 meters. The hull unit can be positioned so that the swing angle is 60 degree. Very good position. What is the ideal loose cubic meter production if the ideal cycle time is 21 seconds. See, this thing can be solved very simply. Optimum height for this machine and material poorly blasted has a factor of 0.5 and multiplied by the given maximum height of cut. So the optimum height of cutting this material is 5.185 meter. Percentage optimum height is as a shovel needs to cut, it is given that it is working at 3.65 meter face, then the percentage of optimum height is 3.65 divided by 5.185. This gives us 70.4%. It means as you remember the table that it is working somewhere between here, percentage of optimum depth. It is between 60 to 80, means 70, and it has swing angle of 60. So you should have a interpolated data between these two. For 60-degree swing and 70.4% of optimum depth, the factor from table by interpolation is 1.08. And the bucket fill factor 80 to 85%, and this value will be taken from the uh, material, the fill factor table, wherein poorly blasted rock is ranges from 85 to 100%. So we are taking the passive estimate of 0.85. Now, for ideal production, efficiency factor is 1, and the total cycle time here will be the loading of the bucket, swing with load, dump load, and return swing. And this total summation is given that it is 21 seconds. Now, placing this value directly into the formula, we will have 3600 multiplied by Q. Q means 3.82. This is the this is the heap volume given in the example, multiplied by bucket fill factor 0.85, which we have taken for the poorly blasted rock, and this ratio of angle of swing to the percentage of the optimum depth is 1.08 from the table, and divided by total cycle time in loose meter cube per hour. This will give the production of the shovel in 601.16 meter cube per hour. This is the way we can find out the production capacity of the shovel using this formula. Now, before moving to the backhoe, if you have any question, please ask. Do you have any question? Okay, I'm moving to the next point. Now, this is a picture of backhoe, which is also called back shovel. As you can have interpretation by the name of back shovel, it has the working similar to the front shovel, but in the inverted position. Herein, the movement of the arm is downwards and the bucket is facing downwards as opposite to the front shovel, and consequently, as front shovel is good for working above the track level, this back shovel or backhoe is good in working below the track level. and the but similar to the front shovel, the performance of the backhoe is also depending upon the factors which is important for the front shovel, such as depth of cut, angle of swing, size of the hauling unit, material which is being excavated, etc. In addition to that, backhoe is also a very versatile equipment, and as you can see in the figure, it can be used to do a lot of different innovative jobs, uh, which unparalleled to any construction equipment present in the today's uh, field of construction. As you can see, this backhoe is transporting a cut tree with its root, and it is holding this tree stem from the bottom by bucket, and it is having taking the support of the boom portion of the shovel. This type of operation is can be performed using this backhoe, and this is not as per any standard operating procedure. This is depending entirely dependent on the skill of the operator, which can perform variety of tasks using the backhoe. Now, components of the backhoe is as such. First arm is called boom, and the attachment which is used to move the boom is called hoist cylinder. And the second arm, which is called uh, a stick or a dipper arm. This the hydraulic cylinder, which is controlling the movement of the stick, is called stick cylinder. And the third cylinder, which is controlling the movement of the bucket, is called bucket cylinder. Backhoe is hydraulic excavator with a bucket attached to a hydraulic control boom and stick. In backhoe, the excavation bucket moves in downward and backward direction during excavation. In as with the opposite to the front shovel, wherein the bucket is moving outward and upward. The difference between power shovel and backhoe is the movement of the bucket, as discussed here. The backhoe is more suitable for the excavation below the ground as opposite to the front shovel, which is better working above the ground, such as excavation for basement in the building construction or trenches for laying sewer lines. The learning requirement for backhoe is same as power shovel, and because of its working below the ground, it is very popular and very useful for construction field, because many construction in the field of uh, city development, road construction, building construction, bridge construction is mostly excavation. In these situations, mainly excavation has been done below the ground level. Now, selection of a hoe for any project depends on following points. First, maximum excavation depth. The, this basically governs the length of the entire machinery of boom and stick, and it governs the reach of the machinery. So, based on this, we can select our machinery and what should be the dimensions of various parts. Point number two, maximum working radius required for digging and dumping. This is also governs how much swing we need, and from up to what distance we have to reach. Third, maximum dumping height required. Because dumping often in backhoe's condition, dumping is often done uh, above the ground. So we need to find out that at what height the material should be lifted, because it may need that it has to cut the material from below ground and needs to fill the transportation unit, which is obviously standing on above the ground. Now, next point, hoisting capability required if needed in case of handling pipe, trenches, trench box, and other material, etc. So, in many cases, because of its versatility, you have seen that the backhoe is also used to lift the concrete pipes, to lift different equipments, and wherein a small lifting and transportation is required. Instead of implying a crane, especially for that, many construction units find the use of backhoe much advantageous as compared to the small crane, because it can apart from lifting and transportation, this machine uh, can also dig for them. So this an additional feature is also kept in mind. All in all, a hoe is a multi-purpose platform. It can perform variety of jobs with little fitment and modifications. Now, the production formula for backhoe is similar to the front shovel, and it is can be seen here. The hoe excavation production in loose meter cube per hour can be calculated by 3600 multiplied by QFE divided by T and 60, where K is the heaved capacity, Q is the heaved capacity in loose cubic yard or loose cubic meter, F is the bucket fill factor for hoe buckets, T is the cycle time in second, E is the efficiency in minutes per hour. Now, after finding the hoe production, we need to have a swell correction, because as in the case of the front shovel, it is not filling with the in terms of gravity, and by cutting the material, it presses the material itself, and we need a different approach of swell percentage to convert the loose material into bank material. So similar to the dozer production, we have to take account of swell of the material, which is being taken from the compacted state to the and transport filled to the transportation unit. Here is the table which indicates the different fill factors for backhoe. Moist loam and sandy clay, which has a degree of cohesion, will have the highest fill factor of 100 to 110. Sand and gravel is ranges from 95 to 110. It depends on the rolling of the material and slipping from the side. Rock, which is poorly blasted, has lowest fill factor of 40 to 50, and rock, which is well blasted and disintegrated into the pieces, is also is have the fill factor of 60 to 75. Hard and tough clay is 80 to 90% of the fill factor. This values are provided by the Caterpillar company. Another material table is showing the relation between various aspects of the backhoe. The first column is depicting the size of the bucket in cubic yard. Second one is the machinery factor, which has stick length and maximum reach at the ground level. The next column is denoting the maximum digging depth in feet, and the maximum loading height is also listed here, and the lifting capacity at 15 feet with the short stick and long stick parameters is also given here. Backhoe sample cycle time based on bucket capacity. This this may the cycle time can also be assessed using actual site data, and but for initial calculation purpose, the cycle time can also be uh, find out using bucket capacity. Now, see the situation. This is a very important situation. Uh, if a backhoe is working in such a type where a transportation unit can park and can be placed for loading just behind the excavator, or due to the heavy excavation, it is also possible that truck can be parked here at the cutting depth. Okay? So which position will be better? Now, if you can see the case here, the backhoe needs to cut the material, fill it bucket, lift the bucket up to this level, and take a 180-degree swing and dump the bucket in the truck. Wherein, in this situation, it needs to fill the bucket, take the bucket to only this height as compared to this height in this option, and swing only 90 degrees or 100 degree as compared to 180 degree in this case, and dump the bucket, and it will quickly reach to its cutting position. This will reduce in lot the cycle time, and in turn will increase the efficiency of the backhoe very much. Now consider a productivity example of the backhoe. A crawler backhoe is having 2.68 meter cube or 3.5 cubic yard bucket, is being considered for the use on a project to excavate very hard clay from a borrowing pit. The clay will be loaded into trucks having a load height of 2.97 meter. Soil boring information indicates that below 2.43 meter is unacceptable silt material. What is the estimated production of hoe in meter cube bank measure if the efficiency factor is equal to 50 minute hour and the swell percentage is 35% for the hard clay? Now, see how solution can be done. Size of the bucket is given that 2.68 meter cube means 3.5 cubic yard. Bucket fill factor from table 9.4 for hard clay should be for hard clay is 80 to 90%. So we can take the middle mean of it, and fill factor is 8.5, 85%. Range of optimum depth of cut is 30 to 60%. In this case, depth of excavation is being 2.43 meter, and the average maximum digging depth being 23 plus 27 by 2 means 25 feet. This value can be seen from this tip. For the bucket size of 3.5 cubic yard, the maximum digging depth is 23 to 27 feet. Okay, the average digging depth will be 25 feet, 23 plus 27 by 2. From here, we got the average digging depth. In converting into the meter, it will be the 7.62 meter. Now the depth ratio of the depth of cut to the maximum average maximum is 2.43, because it is written that at 2 point below 2.43 there is a silt is present and it is unacceptable. So all the digging has to be done from 0 to 4.3. So 2.43 divided by 7.62 into 100 is 31.89%, which is greater than 30%. It means it is falling into the optimum cut range, is which is 30 to 60%. So it is lying at 31.89, so it is acceptable. Now, cycle time for 2.68 meter cube or 3.5 cubic yard bucket is 22 seconds, as it can be find directly from here. For 3.5 cubic yard, the total cycle time is 22 seconds. And the efficiency factor is given 50 minutes per hour and swell percentage 35%, which is given in the example. So the total production will be 3600 multiplied by Q, which is 2.68. It is given here, multiplied by fill factor of 85% for tough clay, and multiplied by E, which is 50 minutes per hour. So it is 50 by 60, and divided by cycle time, which is 22 seconds, taken from the table. Now, calculating all this thing, we will find that 310.64 loose meter cube will be the production capacity per hour. Now, for finding out actual excavation which has been done at the site, we have to reduce this material and convert it to the bank cubic yard. Okay, so by converting from loose to bank, we have to divide it by the swell factor, which is 35%. So by dividing 1.35, we can have the bank production, which is 200, comes out to be 230.1 meter cube per hour. This is how you can find the production capacity of the backhoe. Based on this calculated production, you can easily select the right backhoe for your construction work, which based on the situation of site, how much digging you need to do, and what is the bucket size you require, and what is the cycle time uh, you you have. Based on all that, you can find out the production, and by comparing the production, you can relate it that what is the best suited machinery for your purpose. This is all for today's lecture. If you have any question, please ask. Do you have any question? Ankit, are you able to hear me?
Yes, sir.
Okay. Would you like to ask anything?
नो सर, एक बार और दोबारा पढ़ेंगे सर, तब क्लियर होगा।
ठीक, ठीक. I haven't attached the video of working of backhoe, because you are all very familiar with how backhoes are working. and we can see the working of backhoe in everyday's life. So I don't think that you are this commonly named term JCB is any stranger to anyone of you, and I think you are all familiar with working, and possibly you are using it. So, but for this technical detail, this is very much needed for when you are deciding for the size of the backhoe. Okay. So, because there are different sizes of backhoes available in the market and with the different bucket capacity. But commonly we are seeing only two type of backhoes. First one is that wheeled machinery, which is commonly called JCB, and second one is tracked machinery, which is called Pokeland. So, but there are various varieties of the machinery available with different sizes of bucket. Okay, so based on this different, as depending on your use, you can customize your equipment. Okay, and make the best choice of it. Okay, so is there any queries and question from your side? You may ask.
No, sir.
Okay. So I'm signing out for today, and we will be meeting in the next class, and we will be going to discuss about the lifting equipments. Okay. Now the section of earth moving equipment is over, and we are. I hope that your knowledge related to the earth movers is somewhat increases, and now we are going to discuss in the next classes to come about the lifting equipment and the pile driving equipment. And I'm sure you will also enjoy that lectures. Okay, so that's all from for today, and we will be meeting again in the next class. Okay. Meanwhile, as I like to uh, put you in the record that we are basically moving in the unit number 2, and soon we will finish the unit number 2, and as per the directions of the administration, uh, we are going to conduct the unit test for unit number 2 very soon. Okay, so please start preparing, and day by day, and we will be having unit test as similar to unit number 1 in the coming uh, 1 or 2 weeks. Okay. And one more thing, please tell me, are you able to see your corrected grades?
Yes, sir.
Okay, that is certainly different from the initial marks uh, you have seen.
नो सर, डिफरेंट नहीं, वही है, सेम है
अच्छा, चेंज नहीं हुए?
सर। जो अभी टेस्ट के मार्क्स थे।
हाँ जी जी, कुछ कुछ डिस्क्रिप्टिव टाइप थे ना जिनको बाद में इवेलुएट किया गया।
हाँ हाँ हाँ, वो चेंज हो गया था सर, चेंज हो
हाँ,
गया।
वही मैं पूछ रहा हूँ, वही मैं पूछ रहा हूँ।
जी जी,
सो चेंज
चेंज हो
होने
गया।
के बाद फिर अपडेट हो गए होंगे ना?
जी 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 सर,
ओके
अपडेट।
ओके ओके, थैंक, प्लीज प्लीज सी टू इट। अगर नहीं देखा हो तो आप
ओके।
लोग उसको देख लें, ठीक है? और चलिए फिर, दैट्स ऑल फॉर टुडे, वी विल बी मीटिंग ऑन मंडे, नेक्स्ट मंडे। ओके ओके, बाय।
थैंक यू सर।